everyone. In this talk, we have Roderick with us. Thank you all for tuning in once more. And I want to bring up and say thanks to all our sponsors again for helping us with this event. The help was great, of course. And for those of you that just tuned in, be sure to check out on the website. There is job listings there as well. If you guys are into React, which I guess you are, since you've joined this conference, and you're into developing, apps using modern frameworks, GraphQL, maybe you're into the new headless stack format, be sure to check out Crystallize, which is, of course, a platform for the modern. It's more like a backend for your modern front-end apps. And of course, there is also a challenge running from Auth0, which of course you can get, and if you complete it, you get into a basically you're into it getting a couple of headphones from Auth0 as a gift, as a giveaway from their side. So that's all I wanted to say before your talk starts, Roderick. Thank you for being here. Thank you for taking this talk. It's a pleasure to meet, of course, and have you here with us. Without further ado, I'll stop sharing screen. I'll mute myself, and it's totally on you. So thank you again, everyone, for joining. And yep, it's all you, Roderick.
Hi, everyone. Thanks for having me. It's pretty interesting because we got the invitation for last year, and last year is a bumpy year, and then finally we can have it online here. I will hope some of the sharing today will be really interesting or related to you about how to progressively enhance your web application, and most importantly, everyone can stay safe and healthy here. Some of the enhancement we implemented is actually not only by improving our user members' experience, but also make our code base more manageable. And I will share some of it today. A little bit about myself. I'm a product engineer architect based in San Francisco Bay Area in California. I've been in the tech industry for more than 10 years now, including some large corporate startup and some consulting services. I enjoy a lot of building the products on web platform, as well as architecting web app to be high performance and able to be easily scaled up. Web application, in my opinion, can provide the same delightful user experience just like native application, also with the benefit of highly shareable and discoverable content. Product I built including information portal, news, weather, dashboard, and most recently is the dating app. When you hear about Tinder web, the first question or impression comes to your mind might be, wow, Tinder has a web app? Yeah, this is probably the most frequently asked question, and I will recommend you to check it out if you haven't. As you know, Tinder starts from a very native app-focused strategy and has been gaining great success of providing our member a fun and interactive dating experiences. So why do we need to build a web versions of Tinder where our native clients are pretty mature in the market? To answer this question, I'm going to share a little bit about our journey of exploring the potentials and possibility that we can use by leveraging the web technology. Traditionally, if we want to compare native and web application, we can probably divide the strengths of the app into two dimensions, which is compatibilities and reach. Compatibilities means that your application can provide the user more functionalities or better experiences. And reach, on the other hand, meaning that your app or your content can be accessed by more users. Native application has the deeper integration with the device hardware, which means that they have more CPU power or more native hardware API supported for more functionalities. That is the major reason that a lot of people tend to have the impression that native app is fancier than the web app. Web application tend to be more static, But unlike native application, the content of the web is easily to be discovered, shared, and accessed across different devices. For example, your content will be easily to be searched from search index or to be able to share to social media, unlike native applications. We at Tinder realized that not all our members has the luxury to have the latest mobile device with big storage or strong device power, or like lightning network speed or unlimited data plan to run our native client, especially for our international markets. Even when we are in the country with good network coverage, we all experience sometime when we are traveling from place to place or in a dead spot that the network just slow and spotty. So we want to have all of our members able to use the app anywhere with relatively light required resource. And just in time, the most exciting thing here is the landing of PWA, or Progressive Web App. PWA is a collective of the web technology which helps to bridge the native and the web world, which means that it has the benefit of being able to reach more people and able to have a lot of functionality, which is the compatibilities. Let's talk about it. So what is PWA? There are three main pillars that can make a web app qualify as progressive web app, which is installable, reliable, and capable. Installable meaning that your web application can run in a standalone window instead of a browser tab. The installed app can be launched directly from user home screen or docs or text bar. The experience of searchable and switchable app just feel like an installed native application. Technology-wise, we use Service Worker and Web Manifest, which is supported by all the modern browsers. You can even publish your web app into Samsung, Microsoft Store, or Google Play right now. Tinder actually published a light version of the Android app called Tinder Lite using Trusted Web Activity, or TWA. And the size of the app is extremely compact with almost the same functionalities our native client provided. Other benefit of installed web app, including that it will be easily to deploy doing bucket testing or update the content to the end user without user update or download the new app versions compared to the native app. Your app need to be running in a reliable way regardless of the network conditions. In other words, this is the focus of web performance. This is probably the most important area to make your web app to stand out and feel like native applications. At Tinder, we've spent majority of our time develop and experiment different performance strategy, including code splitting, network priority fetching, pre-caching, and more. There are a lot of good tools that can help you to benchmark your performance strategy, such as Lighthouse and Web Page Test. Capable, as I mentioned before, native app used to have much more access to the device functionality. So that means that browser sometimes just cannot use those API to access some function. However, this is drastically changed recently. More browser APIs published to fill the gap, and more importantly, different browser vendors now working together to form a better open web standard. Sometimes you can almost use a brand new API across all the modern browser in almost the same time of period. I will introduce you some fun browser API we use at Tinder that makes our user experience much better. The first API I'm sharing here is not a new one, but just recently got wider browser support, which is the Media Stream API. It supports streaming video and audio. It is part of the WebRTC feature group, and there are more feature adding recently by the vendors. We use Media Stream API to customize the in-app camera at Tinder. The API will stream user camera, and then we can render our page using HTML5 canvas. This provides us a lot of flexibility to customize the in-app experience compared to the default device camera interface. To access the stream object, you can just call navigator.mediaDevice to get a compatible user media. You can use HTML video to stream the user camera, or in our case, using Canvas to render more customized frame. If you're developing some feature related to video, this might be very helpful for you because you can even add like VR or AR filter in runtime. So for Fallback that's not supporting Media Stream API, we changed to use native HTML5 input elements, allow our member to upload or capture photo from their device. I would strongly recommend here that we always seeking for HTML native support before moving to different JavaScript solutions. HTML spec usually have wider support related to rendering performance and accessibility features such as keyboard or voice-over function. In fact, we actually roll out this solution first at Tinder. Then we progressively adding the new Media Stream API support to improve our members' experience. This example showing one strategy of delivering our feature. We start from the solution that works for majority of our target device and enhance the experiment by progressively improve the code base. At Tinder, we actually use this approach to our core feature, which was the feature that everyone need to be accessed regardless of your device. Those enhanced features will be available in modern browsers, and eventually everyone will be able to use the same experience with tech upgrade. There's some browser API allows you to provide a better personalized experience. I'll categorize this as user preference APIs. It including areas something like data consumption, motions, or color preference. And the example here is like as a front-end developer, we all love like fancy animations. However, this might not be good for all our members. Motion sickness is much more common than you thought. User suffers from motion sickness will not appreciate some effect like parallax scrolling or rapid complex UI animations. For members or users, you can opt in reduce motion in most of your device settings. If user opt into the reduce motion mode, we want to honor the preference and provide a more static version of our web app. You will be able to access the motion preference settings by either JavaScript or CSS, and we can disable the UI animation or transition globally. At Tinder, we use a universal CSS media query to disable animation. Notice that we still keep a very short animation or durations. This is for the JavaScript component that listening to transition or animation end can still function properly. For browser that's not yet supported this media query, we'll simply just fall back to the default behavior. There are some other user preference APIs, such as prefer color scheme, that is for dark mode and light mode. And there's some APIs still in draft, like prefer contrast or prefer transparency. This API exists not only for user preference, but also a lot of time is for accessibility reasons. It is really important for us to make our web app accessible to all our users. No user should be left behind for accessibility reasons. The next one I'm sharing here is a Webshare API, which is a really interesting and easy to use API. This is part of the compatibility project that's currently ongoing by browser vendors in order to fill the feature gap between native and web. This API is especially useful if you're building a media content-focused app or your web app has a lot of sharing features. This picture probably recalls some of the good memories of yours when you try to build social sharing features. The problem is that there's tons of different social media might want your user to be shared to, but there's only limited space you have, especially for mobile web. The social media industry also rapidly changing. Lots of new app is coming up, especially if your web app is international and have different age demographics. In order to decide which social media you want to share, you probably run some experiment to try out to find the best combination which benefit most of your users. The results could be very different, depends on your user demographics such as age, gender, or locations. That is to say, this is probably not the best personalized experience we could provide. And for the implementations, you will most likely rely on each social media site tech spec and constructing different payload, which could, again, be very challenging to maintain. At Tinder, we use the Webshare API to share our user own web profile. The Webshare API allows you to use the device native sharing mechanism. With the standardized payload, this API preventing us building tons of different social media bottoms, and user can choose their favorite app to share the content. Webshare is a promise-based API and can be used to share URLs, text, or files. The implementation is pretty simple. Just code navigator.share and passing the standardized payload. You could even make your web app to receive shared data, utilize the recently launched Shared Target API, and register your web app in just like native applications. You notice that I have conditionally checked here if the function is available. We handle the fallback logic differently this time. First, let's see what is the browser coverage of this API. It looks like a lot of red here, but due to the nature of this API, this is mostly used for mobile device. You can see most of all the major mobile browsers support this API, while desktop is currently developing. This brings up to my next sharing about adopting a new browser API. What if we want to support more browsers? This is the critical question that when we are adding a new feature support. What is your target device and browser metrics? Knowing the breakdown of our the user device will help us to form different strategy of how we're going to deliver the feature. In this example, for the fallback, there's a couple options we can have. The first option is to fall back to the sharing bottoms. You can do it because most of this browser, the API is not supported for most of the desktop, so we can have the sharing button on desktop, and because desktop also have more space to put the widget. The second option here, which is also we use at Tinder, is to fall back to copy to clipboard. We check if this share method exists in Navigator, and then we fall back to the handling logic. This is another pattern I'm sharing here when you adopt a new browser API using fallbacks. For fallback, you can either adding a completely different UI logic, or in some case, you can achieve by some JavaScript polyfills. For instance, canvas to blob is not supported by old Safari, but it can be polyfilled. There's some interesting API aiming to make the installed web app to become more native-like. One important API is the app badging API. The badging API provides a way to set application-wide badge on the app icon, just like native application. You can set the notification count by calling navigator.setAppBadge. This API is available in service worker scope as well. So if you can utilize web push or periodic sync API to update the app badge on the background. Related to this feature, there's another API called Shortcut API, which allows you to create an app shortcut for a user to navigate when they long press the app icon on mobile device. The badging API has pretty decent browser support, and especially if you're developing like desktop app using PWA, this will be a nice API to try out. Browser not supporting the badging API simply will just do nothing. Related to all these new browser API, I want to mention a project called Project Fugu. This is the project driven by the Google Chrome team and focusing on the browser compatibilities. You'll be able to see a full list of the new API as well as their roadmap. You can also become early adapter to opt in the original trial for experiments and feedback to the team to form a better API standard. This is the example of the Project Fugu. There are lots of exciting features such as the contact picker API, allow you to access users' device contacts. The web OTP API allows you to autofill the OTP code if you have the app requiring SMS verification. At Tinder, we utilize the web OTP API, and we see a higher successful rate for user login using SMS authentication. You can access a list of API here to see the progress, the release date. There's some upcoming API like idle detection, virtual keyboard API, PWA as a URL handler, just like native intent, will for sure make your web app become more powerful. As this is a React conference, so I want to talk about like how we are going to introduce, integrate with all these browser API in the React ecosystem. Regardless if you're just starting a new project or you already have some existing project, what will be the best way to adopt this enhancement progressively? I would say a proper abstractions will be probably the most important key here about how easily you can progressively enhance your web application in scale without introducing massive code refactoring or potentially cause regression issues. React is a component-based library, so most likely you are already doing a good job doing abstractions. I'm going to break down some use case of abstraction and explaining like why abstraction matters for coding in scale. Most commonly, we will have three main use cases for abstractions. Reusable components that share the same UI style mostly, which can be important that if you have a design system. Some common experience also be shared, such as handling accessibility for keyboard and voiceover. Material UI is a very good example of reusable component. Then it comes to that logic abstraction, which could including something like instrumentation or some business logic. In React, we will use higher order components or React hook or some utils function. Finally, some app-level abstractions such as routing, internationalizations, theming, and more. This we will call a centralized application configuration strategy. I will introduce some example and explain a little bit. Let's start from a really basic example. You have a React component that to display a title and an image. This component is widely used in your code base, or you basically, when you trying to display an image, you just use image tag directly. Then you notice that when the component is rendered below the fold, we will still trying to load the image even when the user will not see it at all. This could be even worse when you have a large list of the data that's trying to render the image components. So we want to implement image lazy load. We create a lazy load image here. These components will basically handle loading image only when image is in the viewport. This will help greatly for performance and accessibility reasons. We have some logic here. It's a pseudocode for viewport detection using React hook codes used in viewport here. And the function will return if the component is currently in viewport. Our component will then decide to display a placeholder image or to load a real image. To note here that this is an extremely simplified logic. In the real-world example, there are a lot of things more to be considered, such as how to preload the image, how to preserve the image aspect ratio to prevent layout shift when image loading, but you get the idea here. Traditionally, if we want to get the if the image is in viewport, we probably will use the JavaScript function getBounding client rect and compare it with the window viewport to decide if this component is inside the viewport. The downside of this approach is this is actually not a very cheap way to handle viewport detection, and there's a lot of edge case, especially when you are in an inner scroll. Accessing client width and client height, or like window inner width, will actually cause browser to repent and have some rendering performance issue. There are new API coming up called Intersection Observer, which let the browser to observe the component visibility for you rather than continuously keep checking the viewport. This API is supported in all the modern browsers and has proper polyfill available. I didn't put the implementation details here, but it is very straightforward and has a lot of open source library already using this technology. Notice that when we migrate the new method, because we have a good abstraction using React hook, nothing needs to change from your component and the place that they use the components. We can maintain backward compatibility and smoothly enhance your code base. Plus, it will be very easy to test. What's even better here, browser recently now supporting image lazy load natively. We can just add an attribute called loading equal to lazy, and this can be adopted to image or iframe. We can then feature detect this if browser support the image lazy load attribute and conditionally adopt the previous logic if they are not. In fact, if you check the HTML spec, the browser actually implement the image lazy load native using Intersection Observer under the hood. In the future, once the majority of our browsers support this feature, we can just remove the conditional logic and everything will remain the same. So the above example I mentioned is talking about if we have a good logic abstraction, it will be very easy for you to adding enhancement or swap out the logic black box for and all other your component would not be aware of if this enhancement being placed, and it can be placed in scale. But when we start to abstract a component logic, one thing to be very important that if you find out the same logic is scattering across your code base, it might be good for you to move up the logic in the higher order level. For example, if you have a place that keep checking if this user is in want to prefer dark theme, probably will be good to put this data into an app level so everyone will be accessing in the same place. I would suggest you store some global condition in the app level. This will help us to progressively control some common logic handling, such as disabling the app animation we mentioned before. We could also utilize React context to store this condition, and when they update, everything downstream will have the same behavior. App level abstraction enable us to have a coherent experience across different the older app, and we will start forming a good strategy app-wide without touching a lot of code inside the component. Your component or your container won't need to be aware of this enhancement, and your code will remain the same, and the enhancement could be adopted in great scale. I'm going to use routing as an example of the app level enhancement. Routing is what part of the most important part of a single web application. It handles client-side navigation and page rendering logic. I'm going to use a very popular library for routing is React Router as an example. The most basic code structure here is to have a switch component at the top layer and handling the component by route. You will soon develop a route-based component and architecture, and this structure makes it very easy to understand from top level that your main purpose of each route. In our example here, we have 3 routes: is about, a user, and the home. These will have the relative different components handling the rendering logic. What's even better here is we can support route level of the code splitting easily. In our example here, we utilize React Lazy to dynamically load the chunk when the page is navigated to the route. This will prevent the main bundle keep growing when you develop new feature, and the performance will be degrading if your bundle size keep increasing. Do we need a abstraction if we already have the app level component-based strategy? Some common use case here is like if we want to handle page animations, like when you enter this page or you access this page, what will be the animation look like? The other functions, some such as on enter actions, you want to assign, or you want to assign meta tag for each route. Where will be the best place to put these informations? Obviously, the most straightforward place is to directly put inside each route of the components. In our example here, it will be about, user, and home component. The downside of this approach is that your route level components start to be aware of which route path it is currently in. And if we want to share the component, we start to complicate the logic that needs to have conditional logic handling different route contexts. What we can improve here is to move to a centralized app routing config. Standardize how your layout and the route is rendered. For example, we could provide a meta title in each route config for SEO purpose, and even provide animation style for enter and exit. Perhaps you have some page is 1 column layout and some is 2 column. We could also standardize it to just provide the slot and read from configurations. Some benefit including there will be a clear abstract, create a very clear or clean high-level app structure, and easily to progressively enhance your layout logic, such as if we want to add a preload prefetch to a next route, or you add different animations. You could even swap out the whole routing library if you decide to change to other client-side history management strategy without touching any of your component, and it will be easily to migrate and test. One common example here is to add a preload logic. I just mentioned that we have using a image lazy load, routing lazy load using React Lazy. And let's say we have a higher order component, which basically wrap your current component with React Lazy and Suspense. If you are not familiar with React Suspense, it basically is a conditional logic that helps you to hold the loading state until the child promise is resolved. React Lazy utilizes JavaScript dynamic loading and be able to load the component in the separated chunk. This example here, we created dynamic loading components and only load the chunk when we navigate to that page. However, as the loading is separate chunk require network fetching, user might see a delay when they navigate to the page before the chunk finish loading, especially when the network is slow. What we can do here is easily to add a preload function, and which will invoke some common user experience, such as when mouse over or when the link is within the viewport, then we invoke the function to preload the assets. We can call the handle route preload function and just preload the chunk in advance. Such enhancement will not change any of your existing routing architecture, and you could easily roll out to all your pages. We can even do better here. For example, we only want to preload the assets on the browser idle time. This is to prevent some UI jankiness caused by the high CPU usage. We can just wrap the preload function with a request idle callback, which is a new API. Then we complete another round of the progressive enhancement. Request idle callback could be fallback to set timeout. Can we even do more? One concept we can have here is called adaptive loading. Traditionally, we usually have one or few predefined strategy of how we're going to load our assets. For example, image prefetching, you might run a bucket test and find out the optimized value of concurrent networks that can allow you to download the image. But the value is predefined, and it's not really reflecting all the user experience in real world, especially for people considered outlier from statistic point of view, might suffer from the loading strategies. Adaptive loading is an umbrella of implementation using different browser APIs to dynamically provide different loading strategies in runtime. One of the foundations of adaptive loading is Network Informations API. This API provides access to system current network conditions. The API is relatively new, but is supported by major of the Android device, which might be the device that is sensitive to the network conditions. For example, you can know if the current effective type of the user network by accessing navigator.connection.effective type and returning like slow 2G, 2G, 3G, or 4G network. This value is determined using a combination of recently observed round trip time and download value by the browser. You can also check if the user is on data saving mode by accessing navigator connection save data. And we can serve a smaller size of the assets to user if they opt in for the data saver mode. Initially for the preload routes, we roll out to all our pages. However, we noticed that when it is in really slow network conditions, the preload assets actually competing with the concurrent network that browser available with other high priority resource and make the page load even slower. We decide to only preload the assets when we are in good network conditions. As we have the centralized app functions and configurations, the enhancement could be done very easily just adding the condition on the abstractions. We also have several adaptive UI examples providing different user experience based on network conditions. For example, we use a video tag to display animated GIF, and we disable autoplay when user is in either bad network conditions or they are opt into data saver mode. We also selectively pass a poster attribute of the video component, so the browser will only download the poster image without fetching the real video resource before user interactions. This will greatly help the network download performance, especially when users are in bad network conditions or they just don't have the good data plan that can download a lot of resources. By utilizing the Network Information API, we see an uptake of some of our core user metrics, just like page view or lower bounce rate. Some benefit of centralized architecture, including like logic isolation, will force a standardization across your component strategy, and most importantly, will be easily to add the progressive enhancements. To sum up, the gap between the native and the web application is reducing greatly, and there are some much more the web can do with PWA. If you are traditionally like you have a native app and you have a web app, it will be a good time for you to think that what you can use the power of the web technology to help you to improve your business rather than just use web to convert everything to the native applications. Whether you have a new enhancement to add or trying to break down the you supporting device and decide what will be your fallback strategy, And always be mindful about the abstraction, as they will make your progressive enhancement much, much easier. It will be good to start from the beginning, but if you already have the code base, it will also be good to progressively abstract the component first before adding any new logic. Then you can have a testable and also easily to benchmark code base that will help you to expand easily. Yeah, if you have any questions, you can reach me out at the social media here, and then that will be my presentation today.
Awesome. Thank you, Roderick. Thank you for the really nice tips throughout the talk. I think that, guys, everyone can reach out directly to you if there's any questions, or if you want to say hi, right? Social media. So as far as the conference goes, we'll be taking a break for around 10 minutes, and then we'll proceed with our next talk, which is Sam Bellen. So if that's it, thank you so much, Roderick, for having the talk. And we'll see you guys over in a bit, I guess.